Welcome to the Algebra 2 review for Chapter 2B, right? Unit 2B. We're going to write an equation for the surface area S as a function of the radius R when the volume of a cylinder is 250 centimeters cubed. If you remember, we did this multiple times and we derived the equation for the surface area. Correct me if I'm wrong, but it was 2 pi R squared plus 2 times the volume over the radius.
Can I answer this?
I remember. Go ahead and answer it.
Okay, so it's going to be S parentheses of R equals 2 pi R squared plus, and then parentheses 250 divided by R.
Plus,
Yeah, plus 2. And then parentheses is the 250.
and that parentheses means 2 times 250, right?
And then you divide it by R.
Divided by R. And that is the equation for the surface area. And you remember, if it asks you to find the minimum surface area, and you graph that, you'll see a graph that looks something like this. If you will plug in 1 for R, and you'll see that that will give you about 6 here, and about 500 here. If you set your Y max on your window on your calculator at 500, then you'll see a graph that looks like this, and you'll see that you can find the minimum here by doing the second trace minimum, right? Left bound, right bound guess. Y'all can do that, okay? We could find the minimum there. What if the volume changed to 300 centimeters cubed? This would still be S of R equals, go ahead and help me out.
2 pi R squared plus 2 parentheses 300 divided by R.
2 times 300 divided by R. And the graph will look similar. We would just change it now, and we would go 2 pi times 1, be 6, 600 divided by 1, 600. So we change our Y max to about 600, okay? And you'll be able to see that graph. Painless. All right. Now we're going to go to Chiron, right? Chiron's going to bike 10 miles. And we know that rate times time equals distance. And it asks us to give an equation for his time, t, in hours, as a function of his rate in miles per hour. That means that since we know he's going 10 miles, we can plug in the distance. And if we want time as a function of rate, it means we're going to solve this for t, or time, and get t equals 10 over r. And if we plugged in r, that would give us the time it would take to go 10 miles at that rate.
Can I put T of R
Yes.
equals 10 divided by R?
Yes.
Okay.
Nothing wrong with that. And the next one says, write an equation gives his rate in miles per hour as a function of his time in t hours. We're still the same equation, only this time we want, if you want to write your way, r of t equals 10 divided by t. And this tells us the rate we would have to go to cover the 10 miles in t hours. And ask us the meaning of t of 0. Whenever you plug in 0 to a function for the independent variable, you get the y-intercept. In this case, time as a function of the rate 0. If we go back to part A and plugged in 0 here, would be divided by 0. We can't do that. But think about what this means in context. This does not make sense, so we're going to say no, because
0 represents the time.
this would be the rate, the time, this would be the time it takes to go 10 miles at a rate of 0 miles per hour. Where are you going to go if you're going 0 miles per hour? Nowhere. So it doesn't make sense, right? And what's the meaning of r of 0? This doesn't make sense, because this would be the rate. This would be the rate. You'd have to go in miles per hour to go 10 miles at 0 time. So like no time. I'm here, boom, 10 miles down the road. No time. No time passed. Is that possible? No, it's not possible, so it doesn't make any sense, right? On number 3, we're at 5 minutes. We've got enough time to do this one. The graphs of two rational functions f and g are shown. One of them is given by the expression 2 minus 3x over x. So, remember what we did. We looked at this and we said we can find the vertical asymptote. The vertical asymptote here we find by setting the denominator equal to 0, x equals 0. That's the denominator. Both of these have a vertical asymptote, x equals 0. So that doesn't help us. The horizontal asymptote, though, with a function that looked like this with just x in the denominator, remember we rewrote this as two fractions. 2 over x minus 3x over x. And what's 3x over x? That's just 3. And remember we talked about how as x gets really, really, really big, what happens to this? It gets really, really, really small. It gets insignificantly small. And so this whole thing, this whole function, as x gets really, really, really large in a positive direction, as x gets really, really large in a negative direction, the whole thing gets close to, what is that value? Negative 3. So which one of these is getting closer to negative 3 as you get really, really large in the x, or in the direction, positive and negative directions? The first one or the second one?
First one?
This is negative 3 right here, okay? And this means the graph's getting closer and closer and closer to negative 3. Closer and closer and closer to negative 3. So this is the answer. And I'm going to say because it has a horizontal asymptote, y equals negative 3. And when you did the work up here, that showed that. That explained how you know. All right, that's 7 minutes and 22 seconds. We're going to call this video at that. We'll have done our first thing. All right?
Are you excited for Christmas?
I'm excited for Christmas, yes.
Yeah, that's good.
All right. Oh, I was going to say, if you like this video, be sure to hit like and subscribe, right? And tell all your friends.